Students, today I have explained you shifting property for Fourier, shifting property for Fourier, yes, transform. Okay. Yes, this is the shifting property of Fourier transform. Yes, okay. Now we define what is the shifting property is. If f of p, yes, if fp, yes, is a complex Fourier transform of f of x, then the complex Fourier transform of f of x minus a is equal to, this minus a is equal to e to the power ipa f of p. This is the shifting property for the Fourier transform. Yes, students. Therefore, we can also prove it. Yes, this property, and that is, we can say we have to prove this one. Yes, we prove this property. Yes, we know that. Okay. Yes, we know that minus infinity to infinity e to the power ipx f of x dx is equal to, this is equal to f of p. This is the definition. Now, so this is also f of x. Yes, so that is equation number 1. So f of x minus a. Yes, f of x minus a, f of p, f of x minus a. Yes, this one. Yes, this is again we operating the definition, that is minus infinity to infinity e to the power ipx. Yes, and in place of f of x, that is f of x minus a dx. Yes, clear? Now, here we are also substituting f of x, in this one, x minus a is equal to t. So dx is equal to dt and x is equal to a plus t. Yes. So operating here is limit become the same, because minus infinity, substituting minus infinity in place of x, then again a minus infinity, if we plus infinity, then again we get plus infinity. So limit is the same, minus infinity to infinity. Here e to the power I p, in place of x you write a plus t. Yes, okay. And f of t, and in place of dx you can write dt. Yes, so this can again be written as e to the, take the common scalar term, that is e to the power I p a, which is constant term, minus infinity to infinity e to the power I p t. Yes, f of t dt. Yes, Similarly, by the definite integral property, this can again be written as e to the power ipa minus infinity to infinity e to the power ipx and f of x dx. Here using definite integral property, a to b f of x dx is a to b f of t dt. Yes, and this become again f of p. So this is equal to, yes, this is equal to e to the power ipa and this is f of p. Yes, this is the symplectic property. Okay, students. Now we have to review the modular theorem. Yes, and modular theorem. Yes, next one is we have proved here modular theorem. Yes, yes. Modulation theorem is MO. Modulation theorem. In modulation theorem, for Fourier transform and for sine Fourier transform and cosine Fourier transform. Yes, we have write all these properties. The first one is, which is defined as if, yes, if f of x, this is equal to fp, yes, then, yes, then f of f x cos ax, this is equal to 1 by 2 f of p plus a, yes, plus f of p minus a. This is the, similarly we can prove for the sine and cosine form. Yes, that is, if first part if you can prove, then other parts you easily can prove. Okay, so if fs, yes, for sine, fx, this is equal to fsp, then f of x cos ax, this is equal to 1 by 2 f of s p plus a plus f of s p minus a. Yes, similarly for the cosine transform. Yes, next property is if fc f of x, this is equal to fcp, then, yes, fc cosine transform f of x, yes, f of x sine ax, this is equal to 1 by 2 f of s p plus a minus f of s p minus a. Yes, similarly, yes, next property, similarly we can prove for this for the cos, if, yes, if f of c, yes, similarly for the first property, now we have proved for the sine property, yes, And these the property of the, yes, sine property, and sine is again for the cos property, sine cos property, and again for the sine property. Yes, f of s, f of x, yes, f of x is equal to f of sp, yes, then fc, f of fc, in place of this is c, then here is again no cc, then it is f of s, yes, fc, f of x sine ax, this is equal to half f of, in place of sine, for the sine transform, sine of this is f of sp, this is fc, f of x sine ax is equal to 1 by 2 f s p plus a, yes, minus f s p minus a. But here for cos series, here f of c, f of x is equal to fcp, then f of c for the sine ax, f of s for the sine series you can get, yes, for the sine series. Similarly for the f of s, here is f of s, f of x sine ax is equal to half, this become here is c. If you can calculate, then this you get this one, this minus f of c, here is also, yes, this result you get. For sine series, if you take for the sine of ax, yes, then you take the sine series of both are 4. For the cos series, if you this one, then for the cos series you get f of s, yes,